All right, finishing up my final two examples. Airbag deploys with such explosive force that it's unsafe for children to use. All right, calculate the acceleration of the airbag if it deploys in 30 milliseconds and moves out a distance of 40 centimeters. So what's the information given? Well, we definitely have time. Delta t equals 30 milliseconds. 30 milliseconds. Now we want it in SI, so we need to convert that. Milli, okay, division of 1,000, so we need to move that decimal over. 3 spaces, so 1, 2, and 3. So it's going to deploy in 0.03 seconds. All right. We're given a displacement of 40 centimeters. Again, it has to be given in SI, so 40 centimeters is 0.4 meters. And we're going to say that the bag is deploying to the right. We're looking for acceleration. We need to know another piece of information here. Okay, we need to know another piece of information. Again, the airbag is starting from rest. It's not written in the question, but it's something that we need to be able to make an assumption for. Okay, once you have your 3 knowns and 1 unknown, you can then scan back, and it's basically, again, it's decoding, it's finding the right formula to fit what you know. And in this case, we're going to be using delta D equals V1 delta T plus 1/2 A delta T squared. Subbing in what I know, 0 times the 0.03 plus 1/2. Acceleration is what we're looking for, and 0.03 squared, and we know that this is 0.4. Multiplying by 0, I always like when V1's 0, makes the math a little bit easier. So I want to divide, or I want to get A by itself, so I'm going to divide both sides by 1/2 times 0.03 squared. 1/2 times 0.03 squared. That would leave me with acceleration equal to 888.9 meters per second squared forward. Okay, extremely fast, extremely fast. So therefore, the bag accelerates at 888.9 meters per second squared. I guess I should be using right rather than forward. Okay, so very, very fast, but remember, it doesn't maintain this acceleration for a very long period of time. The acceleration lasts for 0.03 seconds. So it's a very explosive force, but it's not a very enduring force or enduring time frame. Final example. So a golf ball is rolling up a steep hill. It's initially traveling at 5 meters per second. So initially, V1 would be 5 meters per second. And we'll say it's going to the right. It slows down with a deceleration of 5 meters per second squared. So that means my acceleration, it's decelerating. So 5 meters per second squared to the left. It's slowing down, or we want to enter it in as a negative number. So it switches back to right. Okay. Determine how long the golf ball took to come to rest. So we're looking for delta t. It's the unknown. What do we know? We know that V2, it's coming to rest. So we know V2 is 0. So again, we're looking at our possible values here. And we see that we know V1, V2, and A. So that means that we need to use some formula that involves those ones. And we find that this one here will work. So 0 equals V1's 5 minus 5 delta t. So 5 delta t is equal to 5, or delta t equals 1 second. So therefore, the ball will come to rest after 5 seconds. Oops, not 5 seconds, 1 second. There we are. Now, take note of the homework. There are a lot of questions there. The reason there's a lot of questions is because this would be, again, 2 work periods working on this material. So very, very important that you spend the time wisely and get through those questions, because homework and test questions, exam questions are taken from that homework. And I encourage you, if you are being successful, then start skipping to every other. The more difficult questions are going to be the last 10 or so questions on there. So please make sure you do take the time to go through them all. All right. Good luck, and if you have any questions, make sure you do ask in class.